Hello, everyone. Today we're going to talk about working with time series in GoldSim. And I just wanted to upfront make it clear on the agenda today. What I was planning is talking more about the features of GoldSim. How do we work with time series using GoldSim features, as opposed to getting into time series analysis, the theory behind it, or the various types of analyses you can do. Um, I've covered some of those in other presentations, but what I really wanted to focus on today is um, what are the features that you can take advantage of in GoldSim so that you can do analyses. And I realized that the title of this presentation today was calculating statistics of time series or time history outputs. Um, learning some of the things you'll see today, you can do that. Um, in fact, it's important to understand how to work with these features to do those things. So, I guess what I'm trying to say is this will hopefully build a foundation to do that kind of thing. Um, the reason I went this way is because, like I said, I've covered um, doing some specific types of analyses in previous presentations, but it's been a while since we've done a webinar on more of the basics functionality within GoldSim. So, okay, this first model, what I want to show you is, and it's just a brief demonstration, how to first of all get data into GoldSim, into time series, and these time series elements that you see here on the screen, these each represent a different type of data source. When you open the properties of a time series, I'm just double clicking on it here, you'll see down here under data definition, there's this data source option here with a drop list. So each of these types of data sources are represented in these different elements. I obtained some data just from online, some time series data from USGS, and in this particular case, it's flow rate and temperature of a river near the GoldSim office. Well, within about a half-hour range of our office, actually. But anyway, this data set has some issues. If you scroll down, you'll see there's some blanks. And let me just find one. I'll just scroll down until we get to a spot so you can see. Okay, so here's a spot. We have a date set for this point, but we have no values for this column of temperature and this column of flow rate. So if you were to just copy this column of data and paste it into a time series in GoldSim, there would be a problem with it. In fact, let's just do that real quick. If we, in fact, let me just for a demonstration, I'll just copy a part of it and create a new time series so you can see what happens here. So I'm going up here to our toolbar for the different kinds of elements that we have and picking time series. And this is just to practice here. So I'm just doing a paste operation from Excel. This is one easy way to bring data into a time series. One thing to note, by the way, when you enter data into a time series like this, make sure you keep in mind what it says up here next to time unit. If you have date or date time inputs here on the time column, make sure it says calendar time. Otherwise, if it's an incremental counter, for example, 0, 1, 2, 3, and it represents days, obviously you would put day there. This is the default here that you see here is actually a function of your simulation settings. So it means it's probably a good idea to set up your simulation settings before you start working with time series. But I can show you that in a second. What I wanted to show you here is what happens when you have a blank input. And what happens is you cannot continue. You can't even get out of this window until that's fixed. You get this message that says, we don't even allow blank cells. In my previous session teaching this webinar on Tuesday, somebody asked, well, why not just, why can't GoldSim just allow you to choose a way to fill that in when you paste it or when you load it in here? And our answer to that is that we would like to preserve the formatting of the data the way it is from the source, and not be the ones in charge of modifying that value there. So yeah, somebody just mentioned just now, why not run the time series through R or Python to remove or fill in missing data? Exactly, yeah, that's exactly what we would suggest to do. There are a lot of tools to use to do that. Even in Excel, you could do something pretty simple if it's just this one value, right? But the point is, fix the data prior to bringing it in. So I'm just going to cancel out of both of these and just not even add that element, and undo what I did here. So typically, what you'd want to do here is you'd have a sheet in Excel for your raw data, and then formatted data, in a different sheet. Perhaps this is one way, or run it through another program. Maybe you have a script in Python that will do some interpolation or something, with the data. But the point is, you can't have a blank. GoldSim's not going to assume it's 0, for example. That would be bad. We're not going to put in a flag give it a negative number. We're not going to do anything with it. We don't want to be responsible for those, assuming what it should be. And then, somebody else opens a model and works with the same data set, and they do some other thing. Now you have, data from the same source and representing something different. So we don't want to accept, blank cells. So anyway, and by the way, there are other tools that are already built for managing time series that you can look up. DSS View by Army Corps of Engineers, for example, is one that does this kind of thing for you. So yeah, there are things you could do pretty easily there. So locally defined is the default for time series, right? Locally defined is the default, and it just means that you would copy and paste the values in, which is what I've done here from the other sheet in that Excel file. And when I click OK, you see it accepts the data. And also, by the way, it would reorder values. If dates are out of order, it would reorder them automatically when you bring them in. However, if you have dates that are the same value, so for example, if this was a January 2nd, 2008, right here, identical to the row above it, then you get an error. It will not allow that. So you have to have monotonically increasing values of time in the in the time column here, and it's not allowed to have equal values there. So there's just a few checks that are done, is what I'm trying to say, before you bring that in. Okay, without spending a lot more time on it, I just wanted to bring up the other ways. The next way to load data into GoldSim is by automatically importing it from Excel, which is what this is doing. And before I do anything else, I'm going to close Excel. And the reason I'm doing that is because this time series is linked to that Excel file, the very one I just had open. It's good practice to close the Excel file that GoldSim is going to be talking to, especially if you are editing a cell in Excel. So for example, if you double click into a cell within the spreadsheet, it opens the formula bar at the top. In a case like that, or anything where you're in the middle of a process in Excel, interacting with it from GoldSim, the GoldSim side, is going to cause a problem. There would be a conflict because GoldSim opens Excel through COM interface. It's not the way you would do it through a user interface by double clicking an icon and opening the application. It opens it up from, maybe you could think of it like a backdoor kind of a way, and so it causes a conflict, and you'll get it'll pause and sit here and wait, and you'll get an error eventually. And so it's highly recommended to close Excel, the application, before you start working with importing and configuring your import from Excel in GoldSim. And that applies to not just the time series, but other elements that talk to Excel as well. Now, it is possible to have a different Excel file open that's not related to this model, but I would recommend just closing Excel. If you're going to be configuring it, working with it, I would just close it if you can. That's the easiest. Okay, so when I click on, when I change the data source to imported from Excel, then this new tab appears, and this is when it begins to talk to Excel. You notice there was a pause when I clicked on that tab. So now it's open to communication with this file, the one I just had open. And you can look through here and see how you can configure the data. It's all pretty straightforward. Down over here, you see it shows the starting cell, the top of both the date, time, and the values for the data itself. And then you can click Import Now, and it will then load that data. And now we have a problem, because I think I must have oh, I need to go look at that. I need to go look at that file. I must have messed something up in there. Okay, so this one was over here. Okay, let me go back. Yeah, and now I must have changed something in there, but I certainly didn't mean to. Interesting. Well, okay, yeah, so see, it hasn't done the import yet. And so let me try this again and read this message a little more carefully. Yeah, you see how it says the values have to be increasing. And so I think what happened here is perhaps C4 and D4 are not the right places. So I'm just going to click on the button that allows me to go to the file specifically and find the place where I want the time data to start. And you can see right now it's actually highlighting the wrong column. I don't know why. I probably did something in the previous webinar. So let me change that now to the time column. That's what it's asking for, is for the time column. So that would be actually B4. So I hit accept, and then we already know that the other column that we want is C4, not D4. So I'm changing that to C4. And now I hit import, and you see it says complete. So now it's good. Now we're okay. All right, so that's importing from Excel. And one other note I want to make about this is that when you make this connection, like I just have here, that when you run GoldSim, it will read the file regardless of any changes to Excel to that file. If you haven't even touched it, it'll still read it at the beginning before the simulation time begins. And so you'll notice that if I hit run here, and for some reason I have my run controller toolbar way over here on the side, but you can move these various toolbars around, by the way. But anyway, so when I run this, you'll see that right there was a message saying, oh, it's loading the data. So it does take a little bit more time to run the model. And if you start to load more and more spreadsheet data into GoldSim this way, then it will become increasingly longer, that period at the beginning before the simulation runs there. So now we can view a time history of that time series that we just brought in. And I just did that by right-clicking and selecting time history. Okay, so that's that option. The next one is linked. The linked option is another way of bringing data to a time series, but this is really going to be useful mainly for working with a submodel. And a submodel is a whole new concept. If you've never used one, you have to think of it as another GoldSim model. It's a separate entity, like it's another model, but it's embedded inside of this model. And it has all of the same simulation settings and configurations for a model, but it's all encapsulated into a child of the main model. So when I say main model, I'm talking about out here, this model we've been working in, and when I say submodel, I'm talking about down inside of this thing. Okay, so first of all, the simulation settings. Let's go there. Now this is the main model simulation settings. The main model simulation settings are running for 1 year, 2019 to 2020, with a 1-day time step, calendar time. Okay, so what you can do with a submodel is you could, for example, you could say, oh, I want to pre-process a time series that's coming from the main model in here before the main model runs. That would be like a pre-processor, right? It runs at the beginning or before everything else. You could do that. Maybe, for example, I don't know, you want to calculate the mean of all the values in this time series. Very easy to do, and I'll show you the things you need to do it. The first thing, however, is you need to link. You need to link the data definition into the submodel, and that's the next data source I wanted to talk about. Okay, somebody asked, when numbers are imported from Excel, the format of the cells does matter to import the number correctly. If the number format in Excel is like 10,000 with a comma, 10,000 gallons, GoldSim. Okay, yeah, let's talk about that a little bit. If you bring in, well, if you use Excel's built-in formatting, for example, to give it commas to separate thousands of zeros, yeah, it doesn't. GoldSim doesn't handle commas. Now, I'm not sure if you've specified the Excel. Well, we could check it. We could certainly check it. But one thing I could tell you right now is that if you look at the values in GoldSim and you see there is a comma. So for example, if I went in here and I said this is actually 9,450 with a comma like this, if it brings that value in this way, it won't accept it. GoldSim does not parse commas, comma separators that way. So you would have to make sure those don't exist in Excel. The other thing is with dates. Be aware that GoldSim is using the date format of your operating system. So if you, for example, maybe you remote into a machine that is in a different country that uses a different formatting, or if you're going to send your model to someone that uses a different format of date format on their operating system, then GoldSim is going to conform to the formatting of your operating system. However, there are times when Excel might have dates in it that it's not necessarily recognized as a data type. You'll know that, by the way, in Excel. Hold on, let me close this. Let me show you what I'm talking about. So in Excel, you know how like if you hover over one of the dates here, and then you go up here under Home, and then go over here to the formatting, number format. If it says date here, you should be fine when you load it. But if it's a different format and it doesn't say that, if it's not recognized as a date, maybe just a string, then GoldSim's not going to necessarily recognize that, especially if it's a format that is different from what you use in your operating system. So there could be times when it parses it incorrectly. If it comes in as a string and you're using what we might see in, for example, Australia, where it's the day first. I think that's how they do it there, and in Canada too, or probably everywhere else except for in the US. then it might try to reformat when it brings it in. So just be really careful when you bring it in. If you in Excel, if it's formatted as date, if it's the date data type, it should be fine, and it should reformat it when it loads it into Excel, or sorry, when it loads it into GoldSim, it should reformat it correctly. It should work correctly as long as it's defined as a date in Excel. However, just be aware of that. Be aware of the fact that GoldSim is going to parse and display your dates in the format of your operating system that it's using. So just keep that in mind. That's a good question, by the way. Okay, so the next thing is linking. Okay, so I want to push this entire data set. Now I'm talking about all the data of, all these rows of data. I want to push all of that into the submodel because I want to process it in the submodel. Well, in order to do that, you need to reference not just the main output, and that's where we need to talk about the outputs of a time series. To look at the output of any element in GoldSim, you click on the output port, and then you'll see that there are could be multiple outputs, one or more outputs available to you. And with a time series, by default, it's going to have two things. It's going to have the main output, and then it's going to have what's called the definition. That's a secondary output that's available if you need it. In our case, when we link, we need that. The definition represents the entire set completely. The other output, the main output, this one, will just give you the value at the current time of the simulation. So for example, in our model, we have a simulation set up to run from 2019 to 2020. Okay, so that means when I run this model, it's not even going to look at anything in this table until it gets all the way down to 2019. And then it will, on each day of the simulation, whatever day we're on, it will output that one value during the simulation. And so as it walks over time, it just outputs one value, next day, next value, on the next day, the next value, etc. But if you want to pass the entire set as an entirety into another place, like a submodel, you need to grab the definition. Okay, so that means our definition is linked or referenced in the submodel. And you can see that actually by looking at these symbols. The first symbol shows just a triangle. The next one shows a triangle with a dot. This dot indicates that its output is being referenced by another element. In our case, the submodel. Okay, so if I also there's this influence line which you could double click on, and you could also find out information about this. If I expand this a little bit, you can see that it's talking about the definition of the time series. You see it says dot definition right here. So that's the output. The definition is going into the submodel. Okay, enough about that. Let me just go to the submodel really quick and show on the interface how it is bringing in the definition into the submodel. So now I can go into the submodel by clicking on this little triangle right here. Now I'm in the submodel. So don't be confused about how we just all of a sudden switch the screen. We're actually inside the submodel. It says submodel up here. And in the browser, you can expand the browser and see the elements that we're looking at right now. So now what we can do is we can link that time series into a new time series element. And we do that by using the linked data source. With it linked now, if I go to the link tab, you'll see that it's grabbing this locally defined definition, which I have named on the interface of the submodel. So we've put it on the interface. There's an interface. You think of it like a container. The submodel is a container, and on that interface, we've exposed the entire definition of this time series on that interface so that it's available to everybody on the inside. And if you go back over to the interface of the submodel, you'll see I gave it a special name here, or I didn't give it. It's called right here on the definition, locally defined definition. If I click on edit, you'll see here. So that's the name that I gave it, locally defined definition. Okay, so that's available, and now I can do any kind of processing inside of the submodel with that entire time series just by linking it. So I don't have to copy and paste it, in other words. I don't have to copy and paste this data. That makes it for a very clean system, right? If there's a change to the data, to the original data source, I don't have to go and change it in multiple places because it's linked into here. And now I can do things with this time series. For example, in this case, I'm calculating a water depth based on a discharge rating curve, for example. You can do lots of things with it. This isn't actually a good example because you could do this in the main model, but the point is you could do something over the entire set. For example, what is the mean of all the values in that time series? But I'll talk more about that later. Okay, so that's linked. Now, in addition to that, we can get a time history output of the submodel that might be coming out of here and link it to a time series so that it's available as a time series input to the main model. So this one is also linked. You can see linked here. It's linked to the output of the submodel. Whatever we're calculating in there, we can send it out. And so let me just show you that on the interface. Right here, we're calculating water depth using a rating curve, and now it is a time history. If I click on the properties of this output, you can see down here, the output type is a time history. It's whatever we calculated over time in that submodel. And then that becomes available as a definition. So if I click on the output port of the submodel, you can see that it shows this gray triangle. Gray indicates a definition, just by the way, is what that means. But it's now a definition that's available. You can see if I hover over it, it says time series definition. It's available for linking. In other words, that's really the only way to access it on the outside, actually, is by linking it into a new time series so that it becomes a new time series there. I think you can see these symbols if you right-click in the browser and select Show Element Sub-items. There we go. So there's the little gray triangle I was talking about. You can see the input coming in with the other one. So anyway, the next one, the final one, is recording a time series. It's sometimes useful to record a time series if you need it to, for an example would be doing verification. Let's say you had an old version of a model. Let's say it was GoldSim 11.1, and you wanted to upgrade to GoldSim 12.1, but you want to make sure that the results are the same. So a good way to do that is, let's say you have some model output. This element just represents some model output, just random model output we have. I want to record the output. So I create a new time series and I set the data source to recording. And then it just says, well, what output are you recording? So you go over here to recording tab and you say, I want to record this output. And then you run the model, and then it will, after it runs, it will record the outputs of that element. And then what you can do after you run it in an old version, you could then change this to locally defined, and now it's a standalone element that's a source of data that will never change because I've broken the link from the recording. And now you can open this in a new version, and now you can compare results against the same output, make sure that they're the same. That's a really good way to, when you're doing an upgrade to a new version, that kind of thing you can do. But it's also useful for other situations. For example, perhaps you want a time series that is essentially going to become an input, and you just want to generate it on the fly using a model. Well, you can do that by recording it. So, and there are some other applications as well, but that's the way to get time series into GoldSim. Okay, so the next thing I want to do, and I didn't want to spend too much time on that, but all of these things are very important. The next thing is some advanced time series properties that I want to show you. And these, we could go on for another couple of hours to talk about the different ways to represent data in time series. So I'm just going to briefly mention them. And what I'm talking about here is the next list, next drop list down, called represents. Represents is, what happened for the most part. What do we output if we have a time step occur that's between the time points in the time series? What do we do with that point? So for example, if I click on edit data, you'll see here that I have these kind of randomly spaced time points, right? They're not one day apart. So this is where GoldSim is quite a bit different from an Excel spreadsheet. In Excel, you kind of have to assume that each row is your constant time step. But in GoldSim, it doesn't work that way. It's a dynamic simulator. So it could be having any kind of time points, and they could be random time points. They could be randomly generated within the simulation. you might not know when they are ahead of time, right? So um, it's important to make sure we define how the time series is going to be represented in the model. So for example, here we have January 2020, and then we skip all the way to April, um, and we have a value of 1 that goes to 5. What happens between those two dates? Does it stay constant? Does it interpolate? What does it do? And so that's what the represents is for. You can change these to instantaneous, constant over next, constant over previous. The change, they might represent changes, for example. So that's really important. And here's a difference. If I run this model, a difference between instantaneous and constant over next, obviously, is going to look like one's constant steps and one is interpolated. And this model is running for many time steps in between these jumps, right? So GoldSim's going to interpolate or it's going to hold constant. Those kinds of things matter. They especially matter when you have certain kinds of data. So for example, in our case, we might have maybe we have a totalizer gauge out there in the field that is telling us over time the cumulative mass or volume that has flowed through some sort of a meter, right? And so if you put that data in, these are cumulative values. They should always be increasing. That might be how your gauge is reading values, right, and sending it over to your database. So you might have data that comes in like this. Well, in this particular case, if you want the flow rate calculated, and you can see that this is values of tons, right? Cumulative tons that it's reporting here. If you wanted to know what the mass rate, rate of change is of these values, then what you can do is go down to the advanced, click on advanced button, and then this expands down here, and it allows you to check this box that says enable rate of change output, which then allows you to add another output. If I click on the output port, you can add another output that's called rate of change, and that will tell you the amount per time. And notice if I hover over it, it says tons per day, and it says day because in my simulation settings, my time display unit is day. Okay, so keep that in mind. Now, it really matters whether you say constant value over next versus interpolated in a case like this. If you have, a totalizer that is running uh, on data that is not that doesn't have time points that correspond to the time steps in the simulation. And this is especially important if you are inserting unscheduled events into your model, then it could cause a lot of problems. So for example, if we have this set to constant over next, well, we have all these time points in between where it was constant, nothing was happening. And then on the one day where the jump occurs, you have a rate of change that's a spike. Obviously, this is not the way we want to do it. We would definitely want to set this up with interpolated or instantaneous value that's interpolated over time, so that we can show rates that are constant. The rate of change is now constant over those periods of time. This is a better representation using the totalizer method here. Okay, scrolling down, and here's another example of where instantaneous or constant over time may or may not be impacted, depending on whether we're inserting unscheduled events. Okay, so what I'm going to do is for now, I'm just going to make this timed event be a regular time basis so that we don't insert any unscheduled events. We are going to have a model that runs on a daily time step only. And so when I run this model and we look at the difference between instantaneous and constant over next, it turns out that if you have data that has no value, the values are not changing, the values, the time points are 1 day apart and you have a 1 day time step, then everything will match, whether it's constant over next or interpolated. It doesn't matter. Well, except for one place. You can see right here, there's one spot here where we were missing some values. We were missing some time points. So constant over next is doing something different than interpolated. right? Um, However, if you get into a situation where you start inserting unscheduled time points, for example, with this timed event that is inserting random events at random points in time, then let's see what happens. This can happen not by adding one of these in your model. It might happen with reservoirs or pool elements in your model. You might be inserting events, you didn't even realize it. And when you start doing that kind of thing, you'll see that there are differences all over the place. And the reason for that is because GoldSim is being asked to insert an unscheduled time point, for example, right here. Let me just zoom in a little bit. We're inserting a time point right here that's not at midnight, right? It's a random time point, and you told it to be constant over time. So you're going to get these anomalies like this if you have the time series set up to be constant over the next time step. And that will also affect your rate of change output, obviously. So if you're curious about, you don't even see those values that are at the unscheduled events, that's because in your simulation settings, down over here where it says advanced, you can see that we are allowing unscheduled updates. I also, down here, I'm including those unscheduled updates in my time history so that I can see what's happening. If I uncheck that and then rerun the model, I haven't changed anything else. I've just unchecked that one box. And now if I look at this time history, it looks great, except for that one spot, but it's not great, right? We've got a bunch of anomalies, a bunch of differences because of the way the time series was set up. So just be careful. I would suggest in your model, if you are allowing unscheduled time steps to occur, that just every once in a while you should check this and check some time histories in your model to make sure that you are accounting correctly for things during those unscheduled time steps. Okay, so yeah, I think that's all I wanted to show on that situation. Okay, so now let's start talking about how to do functions on time series. So I'm going to open up another example. This is a lookup. One of the nice features of GoldSim is the ability to do a lookup function, just like you would on any kind of lookup table in GoldSim. And I can't remember if that was the one I was going to show. Okay, here we go. Okay, so here's a time series. I just called this, this is just made up data, but it's just some values here. These are unitless values. And you can see over here, they're on 1 day, no, these are 1 month time steps over here. But what I want to do is I want to find out what the value is. Let's just pick a date. Let's say I just scroll down here. I want to know what the value is on January 1st. No, let's just give a different date. Let's say August 1st, 2007. Okay, so I want to make sure that it returns this value of 167. So August 1st, and I'm going to copy that value, August 1st, 2007. And then what we can do is just do a simple lookup. And it's unitless output here, but I'm just going to say August 2007 value. And then we can just do a lookup on it. So drought index time series, you refer to that, and we don't stop there. Right now we need to do a lookup, and this is an optional thing you can do with the time series. So I put in parentheses, and then I just put in a date. There are various ways of accessing a date. You can just type it in directly if you use quotes. So double quote, put 2 double quotes in, and then I just type the date. So that was 8/1/2007. Make sure here that you use the formatting of your operating system, right? So if I was in Canada on a different computer, there, I'd probably say 1/8/2007, for example, depending on how the dates are supposed to be. But you can see right now, it's already grabbed the value. I just hover here and it says 167. So that's the value that it obtained. Another way to do it is by elapsed time. I don't know how many rows we are into that, but let me just check. I don't know if this is even worth it, but I could just scroll down to anywhere. If you scroll down, let's say 1994, okay, August 1, 1994, it says row number 896. So we could say that's 896 months into it. So I could say I think this will work if I said, okay, that's kind of a bad example. So let me just say elapsed time. Okay, so we could put in here some elapsed time, and let's just make up a number. Let's say it's 3,000 days into the simulation. Well, it'll tell you what that is on an elapsed time basis. But one thing you want to make sure of that you do is that that you specify whether it's going to be on a date basis versus on an elapsed time basis. And there's a secondary argument to this that's it's optional. If you do a comma, then if you put a 1, then this is going to be based on a date basis. If you do a 2, then it's based on an elapsed time basis. Well, it turns out that because the data here, the unit is actually just day, that it already knows that it's an elapsed time into the simulation. But if you need to make sure to tell it because you're not sure, then the 2 would be always doing it in elapsed time from the beginning of the time series versus on a date. Okay, so that's how you do a lookup. Now, if you could do some more complicated stuff to get a lookup value that changes over time, and that's what is going on here. We don't really need to worry about too much about what this is doing necessarily, but you can see that instead of referring to a typed-in date, a locally defined date, you can have it be an output of your model to do a lookup. Okay, so why is all of this important? Well, it turns out that you can convert a time series to an array by doing this type of lookup. Okay, so let me show you that. Here's a model that converts a time series directly into an array. And if you're going to do it, the first thing you need to find out, of course, is how many rows of data do we want to convert over to an array. So you might go to the time series, edit data, scroll all the way down to the bottom, and because my scaling factor is so high, I have to expand this column here. But you can see that it looks like we need 3,367 rows for an array. If we want to include every single time point in an array, then we would want that many rows in the array. So it means you go up here to Model, Array Labels, and then you need to create a new array label set, and you can see it's, in our case, 1 to 3,366. So there's our array label set. It's just a whole bunch of rows. Okay, so if we want to convert the time series to an array, well, first of all, why do we do that? Well, you might want to calculate the mean of all those values. That's what this does. And the nice thing about these array calculations is they're built into GoldSim. You just do a mean V. It's mean, and these are built in. You can look at them by right-clicking, going to Functions, and then go to Array Operators, and you see all the different kinds of functions that you can just type in and you have available to you. So there's a little more flexibility on what you can analyze on your time series immediately, just without even running the model. Immediately you have the output at the very beginning of the simulation. That would be the benefit here, is what if I needed the mean of all those values to then walk through time forward from that point in the model. I need this immediately. It's like doing an immediate pre-processing of this time series. So if you open up this expression, this is where we're converting it. Now there's a lot going on right here in this little expression, so I need to walk through it just a little bit. First of all, it's using what's called a vector constructor. That creates an array on the fly. Just immediately it's creating a new array. In our case, a vector. In GoldSim, a vector means a one-dimensional array. It just has a column of data, and it's based on our data type. So if you go over here to data type, you see it says vector TS rows. That's the 3,366 I was telling you about before. Okay, so then what we do is the next part, which is also kind of a compact expression. So I need to walk through that too. First of all, we refer to the time series. Okay, so we've done that. That's the time series right here. The next part is the parentheses. So we're doing a lookup, just like I did a lookup before. However, this lookup is using a variable called row. Where does row come from? Well, row is a built-in variable available to you when you're doing a vector constructor. Only when you're doing a vector constructor or a matrix constructor that it becomes available. And what it does is it causes you to iterate over all the rows in the vector and output the row count. So it's almost like it's like a compact for loop where you start at the beginning of your array and you just walk over the whole thing row by row. And so it starts with 1 because GoldSim is 1 based on its vectors, on its arrays. It starts with 1 and just continues down until it gets to 3,366. So on row 1, this will evaluate to 0. And then you multiply it by 1 day, and then it's got a 2 indicating that we're talking about elapsed time on this time series. So it's going to look at the first value. It'll return the first value in this case. And then it'll go to the next row, and it will go 1 day forward on the time series and return that next value, and so on. And so that's how you build the vector. And so this is a kind of an expensive calculation. As you can see, it's working with 3,000 rows. There's no reason you'd ever want to repeat this for every time step because it's the same for every time step in the simulation. So you'd want to, one way to do that is to put this in a container that only activates at time 0, and then after that it doesn't anymore. So just FYI, to do that container, you would select conditionality of the container, and then you'd come over here and you would say you could specify deactivate if the elapsed time is greater than 0 days, something like that. And then it would cause everything inside this container to stop updating after time 0. And that's the kind of thing you'd want to do in this case. This is an expensive calculation. You don't want to do this every time step. Okay, I hope that makes sense. So you could do other things like standard deviation, and so on and so forth. So that allows you to do a lot of array type calculations. All right, another one that you can deal with is, let's see, just looking through, is shifting, time shifting. Time shifting is pretty important and very useful for looking at certain types of statistics. So for example, let's say that you have a very long time series record. In this case, 1948 all the way to current, or close to it, 2018. And it's daily. It looks like it's daily, is it? Yeah, daily data. So that's quite a bit of information. You can see it even tells you right here, 25,000 records in here. And what you want to do is you want to see, for example, what is the distribution of values in January, for example. What are all the Januaries of all those years that we look at in that history? What does it look like on January 1st? Can I calculate the mean on January 1st? Yes, you can, actually, and you can do it very easily. And you can do it by enabling in GoldSim the Monte Carlo simulation setup. If you have 100 years of record, in our case, we only go from 1948 to 2018, so we don't quite have 100 years. So you'd want to consider how many years of record you have. So in our case, we would subtract 2018 from 1948, and we would set up our Monte Carlo number of realizations to be that value, whatever that might be. And I'm just guessing. I I'm not doing the arithmetic in my head very well, but let's just say it's 65 years of record. So you would run a Monte Carlo simulation for 65 realizations, and keep in mind, we're not really. This is not really a Monte Carlo simulation of the time series. It's we're just using GoldSim's Monte Carlo function to kind of to get our data into a bunch of annual sets, so that then we can look at statistics across those years. For example, that's one way to do it. And so then what we can do is when we run this model, so we just ran it for all of those, and then we can look at a plot that shows us the variations over time um, in probabilities, or we can look at it, you know, on a statistic. So, for example, what's the mean rainfall on any given day for all of those years of record? But the nice thing about GoldSim's time history results is that you can also look at periods of time. So let me just briefly talk about periods. That's defined in the simulation settings. In our case, we have a 1-day time step. However, I want to see monthly and annual statistics. So then you go down here and you select major, minor, and that way, then when you look at these time history plots, you can do it. You can look at the statistics of those reporting periods. So we could look at monthly rain for a given month. What's the mean monthly rain total for this particular month here? And we could also do it on an annual basis. Annual isn't as interesting because we don't have that many years of record. And in fact, the best way, if you're just interested in just the annual or in just the monthly, it might be better to just run this for just 1 year, like that. I just ran it from 2019 to 2020, and then just look at the monthly. There we go. So now we have mean monthly April rain totals right here, which is kind of nice. Very easy to get those kinds of statistics that way. But what if you have multiple time series elements and they are synced? How do you sync them? And also, how do we even do this shifting? So let's open up one of the time series and look at how that's configured. This is, again, an advanced feature of a time series. So you click on the advanced button and then this thing expands down here. Shifting is down here as this bottom checkbox. You check that and then you click on the settings of that and it will show you different ways of doing shifting. And shifting, what it means is on each realization of a Monte Carlo simulation, it will pick a different point in the time series at the start of the simulation. It could be totally random if you want. And so if you choose random starting point, and then you just say there's no periodicity, what that means is on each realization, it just goes and picks a totally random spot. But because we have calendar data that's it's effective, it's seasonal data, rainfall is seasonal, we definitely don't want to do a no periodicity. We'd want annual. And this would make it so if our simulation starts in January, it will pick a random January point. If our simulation starts in August, it picks a random August point. That's what this means right here. However, it's random. We can't predict where it will grab those values, but it will be on that period of time when we start the simulation. So that part's good. But if we have temperature data that's synced to the rainfall data, then we don't want to choose annual, because in each individual time series element in GoldSim will be picking a different annual starting point, and that would be probably bad. So what you want to do is sync them all by using an expression. So you can define yourself where to shift the data to. You can give it a constant if you want and say always just start on this year, but that's usually not very helpful in our type of a case. What we want is an expression that tells us where it starts. And so that's what that expression is doing. And so I'm just going to refer to that. And so now all of our synced time series are going to be together syncing their random starting points or random starting day of year in the simulation. And so this is really just a random starting point. I used a stochastic to pick a random number on a uniform distribution between the start and end time of the time series. So this is just a uniform distribution. You have to define the start and the end based on your data sets, right? The lowest common denominator of your starting time and your ending time has to be defined in order for this shift year to work properly. But that's one way to look at those kinds of statistics. And then let me just show you quickly how you can pull all of this together with all of these concepts that we've been talking about. Here's, let me go zoom back up. This is a model that's in our library, and we have a lot of different examples there. But this model, what it allows you to do is it allows you to do a statistical analysis in some ways of some time series, and you just follow these steps. You can and you can define the time series by just copying and pasting data into it. Let's see, are those values even changing? Okay, they are. Okay, so this is some measured data that's a little over 100 years of record, daily time stepping. And then you have to define your time settings based on that time series. So in here, we would have to make sure that the time that we set up is the same, or it corresponds to the start and end of that time series. We'd have to do that here, and also the time step. And once you do that, then you can run the model and it will generate some outputs that could be useful. It's using time shifting to show you this. So that's what I was just showing you, was time shifting. And it shows you the percentiles of where the daily values are going on each of those years. We can also double click on this chart to see different things like what's the statistic, there's the mean, here's all the histories, and here's one at a time, and flip through them, for example. Double click on it and it will close that, collapse it back down into the dashboard. And this will always show the default that you specify. Okay, if you scroll down, you can see here's all the years in a contiguous run. Sometimes people are more comfortable looking at these kinds of things in this way versus the percentile chart. So you can have them both there. What else? So now we can look at monthly and annual statistics. And this just shows a table with different percentiles for each of the months. And so, for example, if you took the average January flow and looked at it for all the years, then you would get about 60, a value of, or sorry, 56 CFS there. And then it also shows you 10th percentile on the low end, on the high end, 90th percentile. What's the maximum? This is actually max daily, so this is the peak daily flow ever recorded in January. So some of those things you can get, they're kind of nice. If I go back, we can also look at probability distribution. So you could take, instead of just looking at the mean and one of the percentiles, you could also look at an entire probability distribution. And this is for the annual here, probability distribution of the average annual stream flow over the whole year. That's how it ranges. And then you can also do it for each of the individual months. In this case, there's a bit more work being done here that says, it looked at the distribution and said, well, a normal distribution is probably a better fit than a gamma distribution for January. But July, it looked like a gamma distribution fits better. So you can do that, some of that kind of stuff. We're starting to get into an area that it might be better to use R, or Python, to do this kind of stuff. It's not as often that you would be doing this kind of analysis, for a dynamic simulation of a model, but just know that you can do quite a bit of this kind of thing on your time series, this kind of analysis, using some of those approaches that I was talking about. And then you can also correlate. So in our case, I was looking at correlating the empirical distribution that we've sampled from our time series to the formulated distribution, like a normal distribution, for example. So January, we said that's the best distribution is a normal distribution. So you correlate the analytical distribution against the empirical and see if you can get a pretty straight line. That was just one of the things to consider. But what I wanted to show you is what were the methods used to come up with these things. So if you go into the model, let's see, all the way up to the top. Okay, so what we do is we take this time series, and I'm going to go back to edit mode so I can look at things a little better. You take this time series, and if you look at the output port, you'll see there's a definition, and it has the dot indicating it's being used in various places. We're passing this whole definition into submodels that are processing that information. And if I go into one of these submodels, you'll probably see somewhere that I'm doing certain things like here I'm using integrators to calculate the totals. In one case, I'm calculating monthly totals. And so this would probably require an array of months, and it does. We have a vector of months and a vector constructor where we say, if the row is equal to the current month we're on, then integrate. We need the cumulative flow just during that 1 month, and then put it in that row, that first row, and it compartmentalizes the cumulative amounts for each of those rows using an integrator. So lots of things like that. We could probably find a place somewhere in here where we are doing a lookup. Well, not there. I don't remember where, but somewhere in here we are doing a lookup in there using some of those. But anyway, we don't have time to get into all of the details of this. You can access this model in our library if you wanted to see how some of those statistics are being done. But in all cases, using the concepts that I've talked about in this webinar. So that's we're out of time. But thank you for joining. I hope this was useful for you, mostly just in understanding the basics of a time series and how to make it, how to bring data in, how to represent the data correctly, and then how to use its outputs. So thanks again for joining. We hope you will join us next month. And also, I will take a little bit of time right now to answer any questions if you have any. If you want to follow up later on, you're certainly welcome to do that as well. Thanks again for joining, and we'll see you next month. Somebody asked, is the vector constructor for the time series described in the user guide? No, actually. The vector constructor is described for just creating a basic, just a vector, but probably has nothing to do with the time series. So it does tell you how to use a vector constructor. So the vector constructor function is described in our documentation. And also the time series lookup is described in our documentation. So separately, I combined the two concepts together to be one concept or one expression, but they are described separately in our documentation. Yeah, and we probably have an example that specifically is used for converting a time series to an array. In fact, let me just go to our I'm just gonna quickly just go check. Okay, so I found the model in our help system. Let me bring this over and just share it with you. So if you look at this article, it's in our time series and lookup tables section called time series mean. Let me just go back. So if you go to our help center, go to model library software features, scroll down to time series and lookup tables section, and then look for time series mean. Time series mean right here. So I'm pretty sure this vector mean is going to be the equation that you want. I'm pretty sure that's going to be it. If it's not, let me know, but that should be doing it right there. It's going to take this time series, it's going to convert it to a vector, and then it's going to take the mean v of that vector right there. So that's a good question. Thank you. Okay, somebody asked, is it easy to run annual statistics for hydrological year, say June to June, rather than calendar years? Yes, actually, that would be something you could do. So if you go back to your, whoops, wrong model. If you go, well, let me just start a new model. If you go to your simulation settings, then I'm pretty sure what you would do. So if you said June, so you could say calendar basis, and then we would say 6/1 to 6/1 next year. So you'd run it like that. And then let's say you had 100 years of record right here. So we're running a model just from, it's just an arbitrary year. Don't worry too much about the year we're specifying here. It's an arbitrary year, but it runs from June to June. And then you go to Monte Carlo. Let's say you have 100 years of record. So you change this to 100 like that. And then calendar aligned. And then I think in the advanced, we'd want to make sure down here that the start of the reporting year is going to be June. I think that's a key right there. You would do that, and then you would do the similar things we already talked about in the webinar to grab. You would, if you have daily data, so for example, this is set up with 1 day time steps, then you would set up reporting periods. If you just wanted to plot, let's say for example, the monthly statistics, you would just create a reporting step that's monthly here, or you could do that integrator that I showed you that essentially integrates each of the monthly values. And let me go back actually to, and there's probably another example model, a simple one that does just this thing. But this was the integrator I was showing you, where you would probably do something like this. You would say, if row equals month, then integrate the value, and it would put those values into each of the months. So in your case, even though you're running it from June to June, this wouldn't even be different. This would be the same thing. When it's June, it would put it in row 6. If it's January, put it in row 1. So you wouldn't even need to set up anything differently to capture your monthly cumulative amounts, even though you're running from June to June. It would still be fine in that case right there. So I hope that answers your question. Thanks for joining, everyone. I think that's it for the questions. So we'll see you guys next month. Thank you.